In this video, we will discuss about find the power of k size subarrays 1. You are given an array of integers nums of length n and a positive integer k. The power of an array is defined as its maximum element if all of its elements are consecutive and sorted in ascending order, minus 1 otherwise. You need to find the power of all subarrays of nums of size k. Return an integer array results of size n minus k plus 1. So what they are saying is that in the input, we are given an integer array nums and we are given another integer k. Now we need to create a resultant array of size n minus k plus 1. Now this n is the number of elements in nums, k is given to us, right? Now in this resultant array, what we need to do? So see, we need to find out all the possible subarrays of this nums, and for each subarray, we need to find out its power. What is a power? So a power of an array is equals to the maximum element of that array if all elements are consecutive and are sorted in increasing order, right? Otherwise it is equals to minus 1. So for each of the subarrays in this num, we need to find this power. So now that subarray has to be of size k, and for each subarray we need to write its power in the resultant array. That is why its size is n minus k plus 1, because the total number of subarrays of length k inside this array will be equals to n minus k plus 1, right? So now if we see that what is the first subarray of size k, which is 3. So it will be this, right? Then next will be this one, next will be this one, then next will be this, and then next will be this, right? So we are total having 5 subarrays. Here how many are the number of elements? It is 7. So 7 minus 3 plus 1, which is equals to 4 plus 1, that is 5. So total 5 subarrays. So now if we look at the first subarray, are the elements consecutive? So consecutive elements meaning that the first element is some number x, the next element will be x plus 1, next element will be x plus 2, and so on, right? So if the elements in the subarray are present in this form, then we can say that all the elements of this subarray are consecutive. And the other thing is that they should be sorted in increasing order. So now one thing to notice here is that if my elements are in consecutive order, they are anyway sorted in increasing order. Because see, this is a number x, next number is plus 1, next is plus 2, next is plus 3, and so on. So they are already be present in increasing order if they are consecutive, right? So we can only check that are my numbers consecutive in my subarray, because if they are consecutive, then they would already be sorted in increasing order, so we do not have to check for it explicitly, right? So if we see in this subarray, all the elements are consecutive, right? 1 plus 1 is equals to 2, 2 plus 1 is equals to 3, so they are consecutive, right? So for this subarray, what will be the answer in the resultant array? Max element, right? And what is the max element of this subarray? This is 3, right? Now another thing to notice is that if the subarray is consecutive and sorted in increasing order, then always the last element will be the maximum element, right? Because they are sorted in increasing order, right? So that is why in this case answer will always be the last element of that subarray, right? So if we have a resultant array of size 5, or we can say n minus k plus 1, then for this subarray, the answer will be 3, right? Next, we have this subarray. Now in this again, the elements are consecutive, right? 2 plus 1 is equals to 3, 3 plus 1 is equals to 4. They are sorted in increasing order also. So we will take the maximum element, which is 4. So we will write 4 here. Now the next subarray is 3, 4, 3. Now you will see that these are not consecutive, right? Because 4 plus 1, here we should have 5, but it is 3 here. So for this, we should write minus 1 as our answer. So it would be minus 1. Next subarray is 4, 3, 2. Now here again, the elements are not consecutive. So for this also it will be minus 1. Then for this subarray, again, elements are not consecutive. After this 2, we have 5. After this 3, we have 2. So again, for this also, it will be minus 1. So this is what we need to return as our answer, right? So now how are we going to do this? So one of the brute forces that we check for all the subarrays, that first we start from the 0th index and we check k elements, and then while checking them, we check whether they are in consecutive order or not. If they are, then we take the last element. And then we again check from the first index, again k elements, then from the second index, again k elements. So in that case, your time complexity would be n into k, right? So now can we optimize it further? So see, when this was your first subarray and then you moved to the second one and the second subarray was this. So if you notice that in this, we removed 1 and we added 4, right? So can I say that there is just one window of length k inside my array, which I am shifting towards the right at each iteration, and the first element of the previous subarray is being removed and the next element is being added, right? So if I know that when I am moving from this subarray to this subarray, then these elements are common. So if these two were consecutive for the previous subarray, then these two will be consecutive for the next subarray also. So I only need to check that whether this 4 is now consecutive with this 3 or not. If this 4 is also consecutive, then this entire subarray will be consecutive, right? So instead of always checking k length subarrays, we can just compare the element that we are adding into our new subarray, right? So what we will do is, now since we are maintaining a window here, so window will always have a left pointer and a right pointer, which will indicate the start and end, right? So we will take two variables, L, which will denote the left, it will be 0 initially, and R, which will denote the right, so that we will keep as 1. Now why we are keeping it as 1, I'll tell you. So first let's write down the indexes. So it will be 0, 1, 2, 3, 4, 5, 6. Right. So now what we want is that we want to know that in my subarray, how many consecutive elements are there. If I know how many consecutive elements are there, and if for a subarray that number of consecutive elements is equals to k, then in that case we can say that for this subarray answer will be max element, right? And if the number of consecutive elements are not equals to k, that is less than k, then in that case it will be -1, right? So what we'll do is that initially we will take consecutive count variable, right? And we will keep it initially as 1. Right. So see, for the first element, we do not have any previous element to compare it with, right? So this number in itself will always be consecutive. That is why we are keeping this consecutive count equals to 1 initially, right? And we will also create a resultant vector, which will be of size n minus k plus 1. So in this case, it will be of size 5. 0, 1, 2, 3, 4. These will be the indexes, and initially we will keep all the values as -1. Right. Now another thing to notice is, if let us suppose k is given to us as 1, in that case what will be our answer? So k equals to 1 means we need to consider all subarrays of length 1. Then this 1 will be a subarray, this 2 will be a subarray, this 3 will be a subarray. Now if I am considering only single element, so that single element will always be consecutive and will always be in increasing order. And the max element in this subarray will also be this number itself, right? So if k is given to us as 1, then this array itself is going to be our answer. So you can have a condition beforehand that if k is 1, then return this array itself, right? So now when k is not equals to 1, in that case how you will do? So what we will do is we will check for all the subarrays and we will find the count of consecutive elements in them and we will compare it with k. So initially our left is here, right? Our left is here and right is here, right? Now we have kept our right at 1 because we want to compare the current element with the previous element to check for the consecutive rule, right? That is why we are starting our R from 1. And if k was equals to 1, that case we would have already handled, right? So now what we'll do is that we will check that the current element, which is 2, is it consecutive or not? So what you will do? You will check that the current element, which is nums of R, if it is equals to nums of R minus 1 plus 1. So in this case, it will be 1 plus 1, that is 2. So these are equal. Then that means this element is consecutive, right? So you will increase your consecutive count by 1. So it has become 2 now, right? And now this subarray's length is not equals to k, right? So we can move forward. So now our R will come here. R will come at 3. Now this is our subarray, right? Now here we are not removing any element, right? Because right now our subarray was of length less than k. That is why we only moved R forward. We didn't move L forward, right? Now in this case, when you are adding 3, again you need to check that if this current element is equals to previous element plus 1, which in this case it is true. So we will increase our consecutive count by 3. Right? Now if you will see that now the length of your subarray has become equals to k. How are you identifying the length of your subarray? You have the ending index and the starting index. So you can do R minus L plus 1, right? This will give you the length of the subarray. So if this is equals to K in any of the case, then that means we have got a subarray of length K and we should update our resultant array, right? So in this case, our subarray length has becomes equal to K. So we will update this. So now for updating, you will check how many consecutive elements are there. So those are 3. 3 is equals to 3. Then that means we should update the maximum element in our resultant vector, right? So now in this, what will be the maximum element? The last element. And the last element will be denoted by the ending index, which is R, right? So in this, the value will be nums of R. And what will be the index? Answer of L, right? Because this L is denoting 0 and we are finding out this 3 for the first subarray. That is why at answer of L we will put nums of R, which is 3, right? Now when we will move forward, our R will come here, right? Now you will see that the subarray length has become greater than K, so we should move our left also forward. So our left will also come here, right? Now you have added this 4 and you have removed this 1, right? So when you have removed this one, you will check that was this one consecutive. So you will check this one with this 2 because previous to this we are not having any element. So we'll compare this one with 2. So this was consecutive, right? So then that means when I'm removing this one, I should also decrement my consecutive count by 1, right? And now I have added 4. Now I should check whether this 4 is consecutive or not. So it is consecutive. So we will increase our consecutive count by 1. Now you will see that the length of the subarray is equals to K. So we should update our resultant vector, and count is equals to 3, which is equals to 3. So then that means we should update the maximum element in our answer vector. Maximum element will be denoted by nums of R, which is 4, and we will update it at answer of L, which is 1. So the first index, we will update it to 4, right? Now we will move our right forward. So right will come here, right? Now again the length has been increased, so we will move L also. So L will come here. Now here we remove 2, right? This 2 was consecutive, so our count should be decremented by 1. And we have added 3. Now is this 3 consecutive? No, because here we are having 4. Our condition is that the current element should be equals to previous element plus 1, which in this case 5 is not equals to 3, right? That is why our consecutive count will remain as is. And now since the length of subarray is equals to K, we will update our resultant vector. So for updating, we will check is consecutive count equals to K? No, it is not. Then in that case, we should update it to -1. But since we already have -1, so there is no need to update. We can just move forward, right? So R will come here and then length has increased. So L will also come here. Now here we remove this 3. This 3 was consecutive with 4. So now our count will become 1, and we have added this 2. This 2 is not consecutive with this 3. So this will remain as is. And now the length is equals to K. We should update the resultant vector, but our consecutive count is not equals to K. So it will remain -1, right? Then again we will move our R forward. So R will come here. Length has increased. We will move L also. We have removed this 4. This 4 was not consecutive, right? So it will remain as is. And we have added this 5, which is also not consecutive. So the count will remain as is. Again, the length is equals to K. We should update this, but the count is not equals to K. So it will remain -1 only. And then when we will move forward, the R index will cross our nums array. So now we can return this resultant array as our answer. So here we are just looping once inside our array. So our time complexity will be order of n, right? And we are not using any extra space. We just took this one vector which was storing our answer, right? So our space complexity will be constant, right? So let's quickly code this out. So first of all, we'll check that if k is equals to 1, then we will return the nums vector itself. Otherwise, we'll create a variable n which will store the size of nums. Then we will create a variable L which will be 0 initially, and we will take a variable count and it will be 1 initially, count of the consecutive elements. Next, we need to create a resultant vector. Let's suppose answer. Its size will be n minus k plus 1. Initially, all the values will be -1. Now we will run a for loop of R, and R has to be started from 1, right? And it will go till n and we'll do R plus plus. Now inside this, we will check that is the current element a consecutive element or not. So if nums of R is equals to nums of R minus 1 plus 1, then we will increment our count by 1. Then we need to check that what is the size of our subarray. So if r minus l plus 1 has become greater than k, then in that case, we should move our left forward, right? But since we are moving our left forward, we should also check whether this was consecutive or not, and accordingly, we should update our count also, right? So before moving L forward, we will check that if the nums of L plus 1 is equals to nums of L plus 1, that is the next element, then we will decrement the count by 1, because in this case it was consecutive, right? And then we will move our L forward by 1. Next, we need to check is the size of the subarray equals to k or not. So if r minus l plus 1 has become equals to k, in that case you should update your answer vector. Now, if the consecutive count is not equals to k, then we need to update minus 1, but minus 1 is already present, so we can ignore that. So if in any case the count has become equals to k, only in that case we will update our answer of L equals to nums of r, right? And at the end we will return our answer. So let's run this now. So our test cases are accepted. Let's submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.